circular linked list. In previous topic, we saw what is meant by linked list and the types of linked list and application of linked list. And based on that, we saw many questions or gate questions we have discussed, okay, in our previous two classes. So in today's class, we are going to discuss circular linked list. Okay. So what is meant by linked list? As I said previously, linked list is a collection of nodes where each node will be having a two field. One is to store the data and another is to store the address field, right? So similar way for circular linked list also, it is a linked list in which the last node points to the head, okay, or a front node. Okay, in your single linked list, normally one node will be connected to the another node. How it will be connected? A first node will have the address of the next node. By that, each node will be connected to the one another, right? So here, circular linked list in the sense the last node is connected to the first node. Okay, so here in this circular linked list, we will be having another two types, singly linked list and singly circular doubly linked list. Okay, so we having the two types. Okay, similar way to our singly and doubly only, but here the last node will be connected to the first node. Okay, so here this is a representation of how our circular linked list looks like. Okay, so here I have demonstrated with the circular singly linked list. So see here, each node is connected to the one another, and here the last node having the connection to the first node, which means the first node address I'm just giving in the last node, right? So by that, the last node is linked to the first node. So this is a representation of our circular singly linked list. Okay, so now we are going to discuss how we can write program to implement the circular singly linked list using C. Okay, so basically three nodes. I'm just taking the three nodes. Okay, so I just move on to that diagrammatical representation. Then we will discuss with the program. Okay, so see here. So this is having two nodes, right? So each node having two field. One is to store the data and another is to store the address. So here I'm having 2000, which means it is the address of our next node. Okay, by just writing the address, which means this first node will be connected to the next. Okay, normally in single linked list, what happens? Last node will not have any address. It will be null. Okay, as it is circular single linked list, or else we can say single circular linked list. Okay, so here I am having the address 1000, which means this is the address of the first node. So it will be like what? Linked to one another in a circular manner. Okay. So next type will be like doubly circular linked list, or else we can say circular doubly linked list. So normally in doubly linked list, each node will be having a three field, right? So one is to store the previous node address, and another is to store the data, and third field is to store the address of the next node. Yes, so here we having two nodes. I have taken the example of two nodes where I am just having 2010. This is the address of the previous node, and this is the address of the next node. Okay, so I'm just representing this using this diagram. Okay, so what are the basic operations we can do in circular singly linked list or singly circular linked list? Okay, it is same as our singly linked list. What are the things we will be doing in singly linked list or doubly linked list? Same thing for singly circular linked list also. right? So here I can do insert, I can delete a node, I can search any node in a list, or else I can display the list of elements. Okay, so these basic operations I can do in a circular, singly circular linked list. Okay, so normally for linked list, before moving on to that, we'll be having a certain basic declaration I need to do. Okay, so for insertion, I'm just using the function insert, and to search a particular element, I'm just using the function find. To delete a particular element in a list, I'm just using the function delete, right? So anyway, linked list in the sense dynamically, I'm just entering with the elements. Okay, it is not fixed. Okay, that's the basic difference between array and linked list, right? So here in structure, I'm just defining the structure where I'll be having the two declaration part I'm just giving. One is data which is of type int. For what purpose I'm just using this data? To store the data, I'm just using this data, right? So next is what means position next. Actually this position is nothing but what? It is the another name I'm just giving for the struct node asterisk. Okay, using the type definition already I'm just giving the another name for the struct node asterisk. So here I'm just using position next asterisk next, which means a pointer variable only will hold the address of the another variable, right? I want to hold the address. Actually that address, if I want to store means that pointer variable only can store. So for that purpose only I'm just using here position next. So one is to store the data and another is to store the address. Okay, so our declaration part is over. Now I need to create each node. Okay. Okay. This is actually a complete program I have given. Before moving on to the complete program, we will I will explain with each operation individually. Then I will just combine the all the operation in a single program. Okay. So first one is about the create. So creation of a node in the sense, as I told previously, the memory allocations are done dynamically. Okay. So how we are doing this means using the malloc function. Okay, so using the malloc function, I'm just creating a node. Okay, size of node. So actually what is there in node? Previously, I'll be having the two variables. One is data and another one, the variable to store the address. I'll be having the pointer variable. Okay, so for that size is 4, and here is 64 bit means for integer it will be 4. Okay, if it's 32 bit means it will be what? 2. So if I'm taking 2 means 2 plus pointer variable size, that will be 4. So 2 plus 4, 6 bytes. So it will be allocating 6 bytes. If it is 64 bit means it will be allocating 8 bytes. Okay, so for a single node, I'll be having 8 bytes of memory will be allocated. Okay, so next printf, enter the node value. So now I need to enter the data. What I need to have in that new node, I need to enter the data. Okay, so that will be stored in the address of new node of info. So next address field, okay, I'm just initializing like null. Okay, no address will be there first in a, while I'm just creating a node, no address will be there, right? So address field, I'm just giving a null value. I'm just initializing a null value. Next, I'm just checking whether my rear equal to null. Rear in the sense what? Our backside. So I'm having only a single node, right? So it is actually null. So my friend and my rear will be what? My new node. Okay. So next I need to create another node, right? So if it is else condition, if it is not a single node, what happens means it will be coming to the else part. If again I'm just calling this create, here I'm just giving with the number of data means again the loop get continues and it will be coming to this else part. Okay, so again I'm just creating a new node and this new node will be linked with the previous node. So like this I'll be creating a list of nodes. Okay, so like this it will be created. I will show you the diagrammatical representation. So like this it will be created. Yes. So now I want to insert the element in this created linked list. So how I can do that? So see here this diagram. Actually, this is a single node which is present in the list. So having the data 20 and having the address 1000. Why it is 1000? Actually, the 1000 is the address of the single node. I'm just giving the same value. Why? Because this single node is linked with the same node because it is a circular singly linked list, right? So here I want to insert the element 20, okay, in the starting part. So already I'm having 10, I want to insert 20. So over here in the beginning part. Okay, so new node with the data 20 is inserted and the next field will be updated to store the address of the start node. So next field of previous node will be updated to store the address of the new node. Okay, so like this it will happen, right? So here I'm having the data like this. Now I need to insert the data 30. Okay, so I'm just creating a new node with data 30 is inserted. So what happens? My next field is updated to store the address of the start node. So next field of previous node is updated to store the address of the new node. So like this, it gets continuous. Okay, for inserting the data. Okay. This is about insertion. So similar way as your linked singly linked list, what we discussed in our previous classes, similar way only we will be writing the program for this too. But the single difference is what now our last node will be connected with the first node. So that is a single coding you need to add extra in our circular singly linked list. Okay, not anything in Greek and Latin. So everything which is known only we are discussing, right? Okay. So here, if I want to delete a node, okay, I want to delete the node. I want to delete the friend node from a list in this program. So what happens to delete a node? We need to check if the list is empty, first of all. Okay, if I want to delete a node, some node should be there no in the list. If no node is there, means there is no purpose of going, no purpose of calling the delete function, right? So I need to check whether the node is present in the list or not. So if it is not empty means there is a point in deleting a node in a list, right? So if it is not empty, then we point the rear node to the front of next and rear of next to front. So what happens? This removes the first node. Okay, so for this I'm just writing the function over here. So temporarily I'm just initializing with friend and just checking the condition whether that friend is equal to null. Okay, so null in the sense what? There is no element present. There is no element or no nodes present in the list. So there is no point of deleting a node, right? So it means it is underflow. The condition is what underflow exists. So it will be displaying with underflow. But if front and rear is equal, the meaning is what? I will be having a single node in a list. Okay, so I'm going to delete that single node. So I'm having where the data is stored in the info. So front of info. So I'm just I'm just printing that node which is to be deleted, and then I'm just initializing the null over here. Okay, so like this it gets continuous. Okay, so next, if I want to traverse a circular list starts from the front node and iteratively continues until the rear node means we need to follow certain function used for this purpose. Okay, so I'm just calling display function. So here temp equal to front, and if front equal to null means I'm just printing empty. Else means I'm just calling this using this for loop. Each data will be what printed. Okay, which will be what displayed, right? So all the elements present in the list, all the nodes present in the list will be what displayed. Okay, so this is a complete program where I'm just merging with all the create, delete, insert, all the operations in a single programs. I'm just mentioning over here. Okay. So this is doubly circular linked list. So similar way, like singly circular list, I'm doing the operation like insert, delete, find, display. All those operations I'm doing here like your singly circular linked list. Okay. Okay, so this is actually find previous. It returns a position of its predecessor. Predecessor means what? Previous node position. It is just returning. So I need to check. So if I want to return the previous position value means to which node value I need to find out that previous. So I need to pass that as an argument. Okay, so to which node I need to find out the previous, I need to pass that, and in what list I need to find out. So I need to pass that list to. Okay, so here I'm just declaring with position p where p equal to l. I'm just initializing and checking the condition. P of next should not be equal to null, and p of next of data should not be equal to x. Okay, so like this I'll be moving one by one. So I need to move traverse to next node. So for that I'll be using here p equal to p of next. Okay, so when that particular value is equal to that particular node, it will be returning the previous value. So that is returns p, right? So this is the function to find the position of its predecessor. So next we can see the routine to delete an element from a list. Okay, so here using this find previous, we are calling and we are finding the predecessor element, and we are storing what element to get deleted. I'm just storing in temp, and using the function free, I'm just freeing the space which is allocated for this temp node, right? So like this. This is the function to delete the entire list, to delete all the nodes present in a list. Okay, so here I'm just declaring with the temp and position. I'm just moving next, and it should not be equal to null. Okay, till then I'm just moving and freeing all the space present in the list. Okay, so and this is a routine to find the next element in a list. Okay, so I need to find out the next element. First I'm just passing two argument. One I'm just passing the node. After that node, what element is present, for that I'm just passing this node. In which list I need to find out, I am passing that list to. So I'm passing two argument. One is a value to find the next element in the list. I'm just passing that node value, and the list as well I'm just passing here. Okay, so here I'm just declaring position p. Position already I stored using the type definition. Instead of struct node asterisk, I have given with position, right? So here p equal to l of next. It is starting from the head node. Okay, first node. So I'm just checking using the while loop. I'm just checking the condition where p not equal to null and p of data not equal to x. If this satisfies means I'm just moving the node next. So p equal to p of next. Okay, so if this is false, in that part it is coming out of this loop and it is returning the p of next. That is the next element to this x. Okay, so next routine to find the element in a list. Okay, so to using the find, I'm just searching the element in a list. So here I'm just moving next, and then I'm finding the element to get searched and just returning the position. Okay, so see here it is traversing one by one and just finding the node which I want to find, and it is just returning the position. Okay, so what are the advantage of this circular linked list? So any node can be a starting point. So we can traverse the whole list by starting from any point. Okay, so we just need to stop when the first visited node is visited again. So this is one thing for circular linked list. I'm just telling. Next, useful for implementation of queue. Unlike this implementation, we don't need to maintain two pointers of the front and rear end if we use circular linked list. and then we can maintain a pointer to a last inserted node, and front can always be obtained as next of last. So next point is like circular lists are useful in application to repeatedly go around the list. For example, when multiple applications are running on PC, it is common for the operating system to put the running application on a list and then to cycle through them. Okay, giving each of them a slice of time to execute and then making them to wait while the CPU is given the value. Okay, so these are some few advantages of our circular linked list. Okay, so where and all we can use this linked list, that is our uses of linked list or else application of linked list. So linked list is applicable in the following areas, like we can do polynomial manipulation, and it can be used in multi-list and set operations, radius sort, dynamic memory allocation particularly. Okay, because array is static and linked list is what, dynamic, right? So these are few applications of linked list. Okay, so we will discuss with some gate questions. So this is a question which is asked in 2004. Okay, so here is a question. A circularly linked list is used to represent a queue. Okay, so circular linked list it will be normally like a queue. Okay, in front all the elements will be added. Right. So a single variable p is used to access the queue. Okay, so if I want to access that queue means a single variable p, okay, is used to access that queue means to which node should p point. Okay, to which node should p point such that both the operations nq and dq can be performed in constant time. In constant time, how this operation nq means what, inserting the element in a queue, dq means what, deleting the element in a queue, so how it can be performed in a constant time. Okay, so that is my question. So here my singly circular linked list, I'm just representing using this diagram. Okay, so where this rear is connected to the front. Okay, so here I need to find out a single variable p is used to access the queue, right? So to which node should p point? P in the sense this one. Okay, such that both operation nq and dq. Okay, because as it is connected in a circular manner, I can delete the element here also, or I can insert the element here also. Okay, in a constant time, I can do the both operations, insertion and then deletion. So that is my question. So here, what will be the answer for this? Okay, so whether it is rear node or it is front node or not possible with a single pointer, or else node next to front. Just a minute. Just a minute. Okay. Just changing. Just okay. So for this question, it is the thing like P point such that both operation NQ, DQ are performed in constant time, right? So here the answer is what na? Rear node. Okay, so P points to what na? Rear node. So next question, why we have taken a pointer that points to the last node instead of the first node? Okay, why have we taken a pointer that points to the last node? Okay, that points to what? Last node instead of the first node. So why it is pointing the last node? So for that they have given me the explanation part here. Okay, so for the insertion of a node at the beginning, we need to traverse the whole list. Also, for insertion at the end, the whole list has to be traversed. So instead of start pointer, we have taken a pointer to the last node. Then in both cases, there won't be any need to traverse the whole list. So insertion at the beginning or at the end takes constant time. Okay, so irrespective of the length of the list, both insertion, that is our NQ and DQ operations, are done at the constant time. Okay, so a node can be added in the three ways. Normally insertion in the empty list, or insertion at the beginning of the list, or insertion at the end of the list, or insertion to a particular position in the list. Everything is possible, okay, at the constant time. So we are telling, so both NQ and DQ are performed at the constant time. Okay, so next question, which type of linked list shows the address of the header node? And I'm reloading again. I'm reloading it again. So we are moving to the question part. Okay. So here, which type of linked list? So for previous, I think it is not shared properly. So I am telling the answer again. So for first question, the answer is rear node. The explanation I have told, both insertion and both deletion can be performed at a constant time. Okay. So next question is like what? Which type of linked list stores the address? Okay. So which type of linked list stores the address of the header node in the next field of the last node? Okay, so whether it is a singly linked list or circular linked list or doubly linked list or hashed list. Okay, so here they're asking in the question what they're asking, what type of linked list? Okay, so what type of linked list stores the address of the header node? Okay, so header node in the sense what? In circular linked list only, a node will contain the address of the first node. Okay, so it can be a circular singly linked list or else circular doubly linked list. But in our option, what they have given, only circular linked list. So we are just moving with the option circular linked list, our option 2. Okay, so next question, it's a detailed solution for that question which we have discussed previously. They have given. So here is the diagram. So here the last node which will contain the address of our first node, which is because it is connected to form a circle, right? So circular linked list is a linked list where all the nodes are connected to form a circular. So there is no null at the end at all. So our last node will be connected to the first node. So where the address of first node will be present in the last. Okay. So next in a circularly linked list organization, insertion of a record. Okay, insertion of a record involves the modification of in circular linked list we are talking. So here if I want to insert the node means where the modification will be done. So here no pointer or one pointer or two pointer or three pointer. So here the answer is like what? 2 pointers. So see here in singly linked list and doubly linked list, the end of the list is indicated with a null value. Okay, but circular linked list do not have ends. So in circular linked list, each node has a successor, and the last node points to the first node instead of null. Right. So example x, if I'm taking as a variable pointer and head. So head is nothing but what? Pointer of a circular linked list. So now to insert a new record, there is a node. Why if I want to insert means we have to loop through the linked list from the head to the last node, like this pseudocode which they have given below. So after finishing the loop, X is now the last node and will suspend, okay, will append the list. So Y is the next node of X. So then the next of Y will have the point to the head. Since the list, linked list is what? Circular. So this is another question they have given here. So the question is, which type of linked list stores the address of the header node in the next field of the last node? Okay, so here they have given with the option singly linked list, circular linked list, doubly linked list, and hashed list. So what the question they have asked, which type of linked list stores the address of the header? So same thing, header, starting node, everything is same. So same thing here, the option answer is circular linked list. So explanation they have given here, same thing. So our next question is, in circular list, we can come back to same element within time complexity. Right. So in circular list, we can come back to the same element within what time complexity? That is a question. So my answer, so big O of 1 or big O of n or big O of n power 2 or big O of log of n. Okay, so then what will be the answer? Okay, where I need to come back to the same element within that time complexity. So here is the explanation for that. In circular linked list, the last element have added or have the address of the first element, right? So we can come back to the same element with traversing example from 11 to 31, next to 51, next to 73, next to 96, next to 105, again 11. So like that we can go in a circular manner. Okay, so here they have given with one pseudo code and how it executes they are asking. Okay, so for this the answer is what? Now reverses the linked list. So this coding part they have given, this is actually the pseudo code. Okay, so while executing this pseudo code, what will be the output? That is the thing they are asking. So while I'm just executing this, the entire list gets reversed. Okay, so it reverses the linked list. Next, to perform the concatenation, next question, to perform concatenation of two linked lists in big O of one time, which of the following data structure can be used? Okay, whether it is single linked list or circular linked list or doubly linked list or circular doubly linked list. Okay, so to perform the concatenation, if I want to combine two linked lists, okay, the time complexity also they have given we go of one time. So which data structure is possible having this scenario? Okay, whether this is a single linked list or circular linked list or doubly linked list or circular doubly linked list. So see here in a circular doubly linked list there is a pointer which points to the last element. So to perform the concatenation using that node address, the time taken will be what? No, big O of 1. So whereas in a simple singly or doubly linked list, we have to traverse the list to get the last element and perform the concatenation. But that will take what? No, time complexity will be big O of n. Okay. So here So here is the next question. Consider the function x, y, z defined below. So structure node asterisk x, y, z. So here I am just passing with the two argument. One is a node I am just passing, and another one is the data which I want to insert. I am just passing here, and then I am just returning the PTR, and here I am just creating the node. Okay, and then I'm just inserting the data to PTR of data, and then the address to PTR of next. Then I'm just returning the PTR. So above function inserts the element into a empty circular linked list. I need to choose a alternative to replace this blank line. So which one is right? Okay, so answer is if PTR not equal to null, that answer is right. Because in circular linked list, after inserting a new element to a empty list, first and last pointer points to the same element. Okay, so I need to check if PTR not equal to null. So which part it will come? Okay, so here I need to check. PTR not equal to null means it will be returning the PTR. That is the address. Okay, it will be returning that address. So here I am just creating a node, okay, like a new node I'm just creating using this malloc. So if I want to return means I need to have this condition possible if PTR not equal to null. Okay, clear? So in today's class, what are the things we saw? We will just have a glance. So first we saw what is meant by circular linked list and how we can represent the diagrammatic representation we saw. Next, the types of circular linked list like singly circular linked list and doubly circular linked list. Okay, and then we saw with the programs or to insert an node or to create a node or to insert a node or to delete a node or to display the element present in a list. So everything we saw the separate program, and we have just merged it in a single program using the cases. Case one means insertion, case two like that. When I'm just giving the particular cases, that particular element will be what, particular function will be what called. Okay, so next the types of circular linked list, right? So after moving on to this singly, after completing this singly circular linked list, we having the doubly circular linked list. The only common thing is what? Now, last node will be connected to the first node. So last node will have the address of the first node. Okay, and these are the operations we can do: insertion, deletion, searching a particular element in a list, and to display the element in a list. So next, this is declaration part for our linked list we have given, and the routine to insert an element in a list, and to find the previous element, we saw the routine, and to delete the element from a list, we saw the routine. And if I want to delete the entire list, we saw some routine. And to find the next element in a list, we saw the routine. If I want to find a particular element, we saw the routine. Okay, and we saw the advantage of a circular linked list, and we saw applications of linked list, and we discussed with few gate questions, discussing with the singly linked list, circular linked list concept. We have covered, right? So tell me what is meant by singly linked list. So singly linked list, how we can represent means. Okay, I will draw and show you. So see here, it is one node, and this is another node, and this is another node, right? So I'm just talking about a singly circular linked list. Okay, so each node will be having two fields. One is to store the data, one is to store the data, and another is to store the address. Okay, so I'm having the data like 1, 2, and then 3. Like this, I'm having the data for all the nodes, and it will be having the individual address. Like that, I'm giving 1,000, then 2,000, next 3,000. So like that, I'm having the different address for each node. So how this will be connected? First node is connected to next node. Now how this address 2000, if I'm having here, this node will be connected to this node. Okay, and here in the second node, I am having the address 3000, means my second node will be connected to the third node. Okay, and the last node address I don't have, so it will be normally null. This is in the case of singly linked list. But in case of circular singly linked list or singly circular linked list, my last node will be connected to the first node, which means the address of the first node I'll be writing in the last node. So 1000 here it is there now. So it will not be null actually. So the data is 3 and the address will be what? 1000. Okay. So here my last node contains the address of the first node. So this is a diagrammatic representation for circular singly linked list. Okay. So if it is circular doubly linked list, so what change I'll be doing over here? Normally how we will represent doubly linked list? So for doubly linked list, each node I'll be having a 3 field, right? So the middle field will store the data, and previous field will store the address of the previous node, and the next field will store the address of the next node. So like this, if I'm having 3 nodes, so see here I'm having the data 1, 2, 3 like this, and we having the address 1000, 2000, 3000 like this. I'm having the address. So here it is the next field. Okay, so next field address is what? 2000. So then if I'm just giving like this node will be connected to this one, and this address is what? 1000. Then the second node will be connected to the first. It is like bi-directional. Okay, so I can traverse in both the direction, but in case of a single linked list, I can traverse in only single direction, but here I can traverse in both the direction. So next, see here, if I want to link to this means 3000. So this address I am having here. Okay, and again, this will be connected like this. Then this 2000, if I'm just putting in my third node, this will be connected like this. and my last node will be connected to the first, which means I'm having 1000, right? So the 1000 I'm just having here, and my first node will be connected to the last node. So here I'll be having like 3000. So this is an example diagrammatic representation for circularly doubly linked list. Okay, so which can traverse in both the directions. So that is the thing over. Okay, so this is about what na circular doubly linked list. Okay, is it clear? So what are the things we saw in our class? Today's topic is circular linked list. So the only change in our doubly linked list and circular doubly linked list, our last node will be connected to the first node. Okay, so same for our singly circular linked list and doubly circular linked list. Okay, and we saw the applications also. Revise with that. Okay, so these are the basic operations like creation, insertion, deletion, traversing a node in a list. We are doing here, and this is the complete program and the output for this program, and this is the diagrammatic representation for our singly circular linked list and doubly circular linked list. And we have discussed with the operation, and here we have discussed with the declaration part. Here I told you the type def is nothing but what I'm just giving the another name for this struct node asterisk. Okay, using the type definition, I'm just giving. Okay, so that is the thing about type def struct node asterisk position. Okay, and here I'm just writing the routine to insert the element in a list. Okay, so I'm just creating using element. I'm just creating the node using this malloc. I'm just creating. If this new node is null means I'm just printing with out of space, or else I'm just inserting the element in the list. Okay, and here it is about circular, singly circular with single node. And then here a new node with data 20, I'm just inserting here. And the next field is updated to store the address of the start node. Okay, and here see a new node with data 30 is inserted, and the next field is updated to store. And to find the position of its predecessor, we saw. Next to the routine to delete a particular element from the list, we saw. And the routine to find the next element in the list. Okay, and to find the particular element in the list and the advantages, applications, and we have discussed with the gate questions. So go through with all the gate questions, which will be very helpful for you to um, prepare for your gate exam. Okay, so just go through with all the previous year question. It will be very useful for you. Okay. So with this, we are coming to the end of the session. Okay. Thank you, everyone. Thank you, students. Thank you, Ma.